Good morning, Algebra 2 students. Hope everybody's had a great weekend and a wonderful Saturday and Sunday. Looking forward to covering some material with you guys through video these next couple of days. What I thought we would do today, I'm just assuming a lot of you had a very busy weekend and probably got to work a little bit on your homework, but as you worked on your homework, I'm assuming you guys ran into several different challenging problems and you may have just gotten stuck. So what I wanted to do this morning is I wanted to take a look at some of the problems from lesson 6.2. So go ahead and take out your homework. We're going to look at that, possibly just a couple of them. Actually, you'll probably just turn that in. And then I want us to take a look at some of these problems in the textbook. So open your ebook, open up to page 245. And we're going to be looking at a couple of these problems, and I'm going to be working them on the screen. I want you to work them with me so you'll have them to reference, because you guys are going to be working on some more of these problems tonight. So if you're hopefully already on page 245, let's take a look at number 27. 27, we have a function. It says write the function in vertex form and then graph the function. Remember, guys, vertex form is the form that I'm writing up on the screen now. F of x is equal to a times the quantity h minus x squared plus k. All right, so we got to get it in that format in order to graph it. We're graphing the quadratics, which actually end up being the shape known as a parabola, and this is what we worked on. So everybody take a look at number 27. It says f of x is equal to x squared plus 6x plus 5. And the instructions say write it in vertex form, which would be this form right here, and then graph it. So we're actually practicing a little bit of everything today. All right, so on this particular problem, what we're going to end up doing is, remember, to get it in the proper form, we need to complete the square when possible. So that's my very first step. I'm going to write x squared plus 6x. I'm going to leave a space and put plus 5. All right, and all my work is going to be done on the right side so we can reference it and you guys can take a look at it. The steps to completing the squares: once you get everything on one side, you take the number next to x, which in this case is 6. You take the number next to x, you half it, and then you have to square it. So half of 6 is 3. 3 squared is equal to 9. So I take that 9 and I put it in the little spot right there that I left. Remember, in math, you can manipulate equations, but you can't change values. So since I added 9 to this side, I need to also subtract 9 from this side. So that's what I end up with. And now the whole purpose, if you guys can remember this, I needed to get this piece that I'm underlining in red. That's the perfect square. So now I can rewrite this in the vertex form. X goes first. I'm closing my parentheses and putting squared. The number before you squared it goes in the parentheses, plus 3. And then I need to add what's on the outside. In this case, it's 5 minus 9, which would give us negative 4. Now I'm in vertex form. Now I'm ready to graph the parabola. So you have to remember how to complete the square in order to be successful. So next thing I'm going to do is go ahead and draw my Cartesian plane. And I have to remember what all these pieces are. The number next to x is the axis of symmetry. Now remember, in your equation here, it's minus h. You guys can see it right there. I'm circling it. Since it's minus h, we do the opposite of what it says. It says plus 3, but I need to go to negative 3. And I draw a dotted line. And make sure you're doing this with me. It'll help you out tremendously, so make sure you're writing these steps down as we go through them. After you find the axis of symmetry, you can go ahead and plot your vertex on that axis of symmetry. The number outside the negative 4 is the vertex. So on the axis of symmetry, I need to go down 4. Don't put a dot there. You put the dot on the axis of symmetry. Okay, so that's great progress with this particular problem. So what I need to do now is I need to at least find another point. I got to find a point in order to be able to graph this. A couple things to note: the number out in front of the a part in your equation, which in this case is just a 1, it's positive, so we know the graph is going to be going up. That's just good point of reference to think through. But I need 1 point. I always pick 0. It's always fast and simple, and you can use a little X and Y chart if you want to, but I'm going to plug in 0 for X. So in my equation right here, I'm going to plug in 0 for X. So I do that, and I get 0 squared, which is 0, 6 times 0, which is 0, and I get plus 5. So 0 plus 5 is 5. So when X is 0, Y is 5. 1, 2, 3, 4, 5. Way up there. Now the next question we ask is how far off of the axis of symmetry is that point? Maybe I should draw it right there. How far off of the axis of symmetry of that is that point? Well, it's 1, 2, 3 off. So I need to go 3 the other way. 1, 2, 3. And I'm going to put a dot right there because it's going to correspond with the dot that's opposite of it. Hence why it's called the axis of symmetry, because it's symmetric. And then I can connect my dots. I draw the line going up, I draw the line going up, and you have just graphed the parabola there. Not a super hard problem, just several steps you got to go through, and you got to make sure you've mastered completing the square in order to be successful on these problems. So now let's take a look at number 29. This one's a little bit different. 29 h of x equals negative 2x squared. Oh, wrong problem, I'm sorry. Negative x squared plus 8x minus 10. Okay, so this one's a little bit different, and this one's the type of problem that you guys may have had some issues on, so that's why I've chosen to go over a couple of these today. The first thing you got to do on this one is get rid of this negative sign. The negative sign right there. So the way I do that is I actually factor it out. And when you take it out, the x squared becomes positive. You just change its sign. And then the positive 8 also changes sign, so now it's going to become a negative 8. Leave a space and put the minus 10 outside. Don't mess with that minus 10. So again, we factored out that negative side. Sometimes it'll have a coefficient. We'll work one in just a moment that has a coefficient. You want to factor it out if at all possible, and that will make your life a whole lot easier when you're completing the square. So I look at my problem, I have it set up right, I took out the negative. Now what I need to do is I need to go through the process of completing the square again. So I take the number next to x, which in this case is negative 8, I half it, and then I square that. So half of negative 8 is negative 4, square that, and I'm going to end up with 16. So I get 16. That 16 goes in the blank right here, so plus 16. But here's a problem you have to be very careful on. You put a plus 16 there, and I know all of you see that, but you cannot forget about the negative that's out in front of this. I really didn't add 16 to this side of the equation. If you distributed out the negative, you would realize that I actually added a negative 16. So since I added a negative 16, I have to add 16 to this side, because adding a negative is the same thing as subtracting 16. So since I'm subtracting 16, I need to add 16 to this side. Once you do that, you're almost done, because you've just made your perfect square. X goes here. The term before you squared it over here is negative 4, so that goes in the blank there. And then you say negative 10 plus 16, which would give us positive 6. So h of x is equal to negative quantity x minus 4 squared plus 6. Now I'm ready to graph it. So you do it the same exact way you did the other problems. First, I need to plot the axis of symmetry. Now be careful. The only thing I care about is the negative 4. Because in my equation, it's that negative h, x minus h squared. So since I'm subtracting 4, I have to do the opposite of that, which would be moving it over to positive 4. So the axis of symmetry is at positive 4. Now some of you may be asking the question, how come I didn't have to worry about this negative out here? Why didn't I do like an opposite of an opposite thing? The negative out in front just corresponds with the a in the equation. Again, the a times the x minus h part. The a is negative 1 here, so you don't have to worry about that when you're looking at the axis of symmetry. The only number you care about for the axis of symmetry is the number next to x, whatever that is. So then the rest of it's the same. After you draw all your axes of symmetry, you can go ahead and plot your vertex. The vertex here is positive 6. So on the y-axis, I go up 6. And I put the dot that corresponds with that on the x-axis. I'm sorry, on the axis of symmetry. So we're looking at our problem. We know that A here is negative, which tells us we're going to be drawing this parabola down. And you'll see that when you pick some points. Again, if I were to do a quick X and Y chart, I'm always going to pick 0 just because it makes it a lot easier. You can pick whatever you want, but I'm picking 0. I plug 0 back into this equation here that I'm underlining. When you say 0 squared, you get 0. 8 times 0 is 0, minus 10. So 0 minus 10 is negative 10. So when x is 0, y is negative 10. That's way down there, but that's what I get. Then I ask the same question. How far off of the axis of symmetry is that point? Well, it's 1, 2, 3, 4 off of the axis of symmetry. So I need to go 4 the other way. 1, 2, 3, 4. Go all the way down. And then there you go, guys. You have your parabola that you're ready to graph. So once you get it, once you get it in the vertex form, it should be very, very simple to graph. The concept or the challenge that some of you have with this kind of concept is getting it to that point. So I'm going to do one more just for practice to make sure we got it, and then I'm going to have you guys do a couple of these for homework just to get some good practice and to make sure you get this. Tomorrow's lesson is based on this lesson, so you really have to know how to do this. But tomorrow's lesson is actually fairly easy because it's just adding one small piece to this concept. So I'm going to do number 33. So if you guys will work this with me on your page, it'll give you some good practice for some problems that you guys are going to be working on tonight. All right, so there's my problem. I'm going to do the same concept here that I did on the last problem. You guys can look at the x terms, and you notice that they both have a 3, a factor of a 3. So I'm going to factor that out in order to make it so that I can complete the square. 3 times x squared is 3x squared. 3 times what gives me 12x? Well, hopefully you just said 4x. Close the parentheses and then put that plus 6 outside. All right, so now I'm ready to complete the square. I take the number next to x, which in this case is 4. I half it, and then I square it. So half of 4 is 2. 2 squared is equal to 4. So I put plus 4 in that spot. But again, be very careful here. I did not just add 4 to this side. Just like on the last problem, that negative impacted my answer. The 3 outside is going to impact my answer. So I have 4 times 3, which is 12. I'm really adding 12 to this side of the equation. So since I'm adding 12 to this side, I have to subtract 12. Again, some of y'all may have missed that. I put the plus 4 here because it was 4 when I did all my work to the right, and that's correct. But I really added a 4 times a 3, which gave me 12. Since I added 12, I had to subtract 12. Well, you just made your perfect square. 3 times the quantity, x squared. The number that goes next to x is the number before you squared it, which is plus 2. And then you say 6 minus 12, which gives me negative 6. Well, I now have the standard vertex form, I should say. I can now plot this and graph it on a Cartesian plane. First thing you do is the axis of symmetry. Here it says it's 2. We always go the opposite of that, so we're going to go to negative 2. Then I'm ready to plot my vertex. In this case, the vertex says negative 6. So 1, 2, 3, 4, 5, 6. Negative 6, that goes on the axis of symmetry. We know this parabola is going up because the A part is a positive. So we know it's going up. So I need to figure out one more point. Again, you can figure out as many as you want, but I just need one. So I'm going to plug 0 in for x into my original equation right here. So I have 3 times x, or 0 squared, which would be 0, plus 12 times 0, which is 0, plus 6. So 0 plus 6 is 6. So when x is 0, y is 6. How far of the axis of symmetry is that point? Well, it's 1, 2. So I need to go 2 the other way. 1, 2. Put it out up here, and there you go. You see your parabola. Now this one, hopefully you guys notice, is a lot more narrow than the ones we've done previous. The reason for that is the A out here is greater than 1. If it's ever greater than 1, it's going to be very, very narrow. Remember, if it's like a small fraction, like 1/2, that means it's going to be very, very wide. So those are some problems that I just wanted to work and show you in order to help you with a couple of the problems you guys are going to be working on for homework tonight. The only problems I want you guys to do are I want you to do numbers 28, 30, 32, and 34. I'll put it up here on the screen so you'll know exactly what's going on. 28, 30, 32, and 34. And then I do want you to practice a word problem. It won't be extremely difficult, but it'll take a little bit of thinking. I want you guys to try number 38. It deals with a parabola, trying to figure out, make some predictions about some future sales and future products. So I think you guys will find it kind of interesting, and you actually can use a parabola in order to figure that out. So those are the problems that you guys will be working on for homework tonight. I hope you guys do well on these. I think you will, but I hope all of you have a fantastic day and a wonderful week.